Generating long-form video currently relies on chaining independent AI models together and hoping the output remains cohesive. This sequential approach focuses on the execution of individual tasks, prompting a text model, then an image model, and finally a video generator, assuming each step will correctly interpret the intent of the last. Building a stable, reliable system requires analyzing how these stochastic agents can be forced to cooperate within a deterministic framework. This requires an orchestration layer that exists independently of the models themselves, enforcing logic across the entire production. Moving toward holistic system orchestration provides the stability necessary to maintain narrative consistency throughout a complex audiovisual project. Standard pipelines are highly vulnerable to stochastic generative drift. In this sequential graph, any minor text hallucination propagates and amplifies through the image and video generators. This linear model also creates a hardware bottleneck. Static memory allocation causes VRAM usage to accumulate at each node until the GPU reaches its physical limit and crashes. Simply replacing the nodes with more advanced models fails to address these underlying structural flaws. Because linear chains force models to interpret previous errors, compounding entropy and unmanaged memory inevitably lead to system failure at scale. The first step in stabilizing the system is decoupling the narrative state from the generation models. We solve this by introducing the semantic ledger, a centralized database serving as the single source of truth. Instead of inventing their own state, generation and planning nodes form a hub-and-spoke architecture, pulling their parameters strictly from the central ledger. Characters and environments are defined as reusable semantic entities within the ledger, rather than being reconstructed from scratch in every prompt. Under this architecture, no individual node is permitted to independently generate new narrative data. Generative nodes must verify their output against the ledger. The data only proceeds if it matches the ledger's constraints. Centering the architecture on an immutable ledger enforces strict narrative consistency across any number of independent stochastic agents. Controlling the unpredictable nature of AI-generated video requires a separate layer for visual planning. We implement this through a camera director AI subsystem. This motion graph defines cinematic language through symbolic camera operators. We use these geometric vector paths to specify movement before generation begins. A dedicated planner module selects these paths, using them as mathematical constraints on the video model's latent space. By selecting the operators first, the system forces the stochastic model to conform to a predefined cinematic path. Separating structural planning from pixel generation provides the control needed to eliminate random morphing and ensure cinematic intent. This centralized logic also addresses the broader research problem of multi-source narrative fusion. We call this framework cross-media narrative semantics. Because the core story grammar resides in the ledger, the narrative data can be translated into different media formats without losing its structural integrity. A single semantic block can be expanded into a novel, adapted into a film script, or rendered as a video, all while maintaining the same underlying data. This ability to perform structural translation across media confirms that the ledger architecture is fundamentally format agnostic. Local production faces a rigid physical constraint, the VRAM limits of consumer GPUs. Attempting to load multiple large-scale models simultaneously results in immediate out-of-memory errors. The adaptive model scheduler solves this by managing memory in real time. It rapidly swaps models in and out of the active VRAM block. Functioning as an AI operating system, it routes tasks based on hardware availability, holding data in memory queues until resources free up. Dynamic routing ensures that the multi-agent pipeline continues to flow without being paralyzed by hardware bottlenecks. Advanced orchestration must dynamically conform to these physical hardware constraints to remain viable. The final component of the system is the continuous self-evaluation loop. Within a deterministic framework, generation is treated as a continuous cycle of refinement rather than a single attempt. The system evaluates every output against the constraints of the semantic ledger, triggering autonomous re-renders whenever those constraints are not met. Determining the optimal balance between compute time and critique iterations is essential for finalizing an autonomous production loop. This completed architecture coordinates every module in unison. Data flows from the ledger to the planner, executes through the scheduler, undergoes evaluation, and returns to the ledger. By automating verification at every step, the system maintains a consistent rhythm without compounding errors. We define this integrated framework as an autonomous producer. This framework serves as a rigorous research platform designed to investigate the mechanics of complex AI production pipelines. Achieving multimodal autonomy requires hierarchical systems that can manage independent models without constant manual intervention. Validating this architecture requires a focus on measurable technical outcomes. We track VRAM utilization efficiency, scene computation time, and overall render success rates to benchmark performance. We also measure structural metrics, including character consistency, story coherence, and the system's ability to recover autonomously from generation failures. The combination of a semantic ledger and an adaptive scheduler addresses the core problem of stochastic drift that destabilizes traditional pipelines. The stability and control required for autonomous long-form production emerge from the deterministic architectures used to coordinate AI, independent of the parameter counts of the underlying models.